questions. If you can do these, I mean, not always the super hard, but if you can do this, if this stuff makes sense, you're gonna get 100% on the test. Seriously. If you can do this, you can do everything on the test. So go through these in your notebooks, and why don't you just write these out as we go. I'll put the notes up tonight, but go through the process with me, ask questions. Let's make sure everybody can do all these problems, and then you got till Monday before you actually have to do this on a test, okay? All right, so complex number stuff. Let's quickly just talk about this. So write the real part and the imaginary part. What's the real part? If this is our complex number, 11 plus I, what's the real part? 11. Good. Awesome. So that's the number that doesn't have an I attached to it. What's the imaginary part? 1. Good. We got questions on that, right? The real part is the one with no I. The imaginary part is the coefficient of I every time. What about this one? 5I. What's the real part? 0. Good. It doesn't show up, so it's 0. What's the imaginary part? Good. Okay, adding complex numbers. Or subtracting, sorry. I won't even do adding. Adding is so simple. If you can do subtracting, you can do adding. What are the steps for subtracting complex numbers? What am I going to do first? Jake, what do I do first? If I want to subtract these, what do I do with that negative sign? Good. Distribute it. Good. We're going to distribute the negative, and then we'll just add up like terms, right? So that's going to give me 5 plus I minus 3. If I distribute the negative, I get a plus 12I. And then I'm just going to add up the like terms. I got real parts, real terms, and imaginary terms, right? Just add the like terms. What's 5 minus 3? 2. So those two add to 2. What if I add these like terms? What's I plus 12I? 13I. Bingo. That's it. Okay? What if you get one like that? It looks a little weird, but it's easier. What's the only thing I got to do is I just have to subtract the 15I from the 5I. That's it, right? There is no real part to subtract here, so I'm just going to get negative 4 plus 5I minus 15I is great. Okay, no big deal. Okay, solve some equations. So let's look at some examples of solving quadratic equations by isolating x. Okay, what's first step? Add 15. Good. I think you guys are getting pretty good at this. So negative 5x squared equals, if I add 15, negative 70 plus 15 would be negative 55. Good. Next step? Divide by negative 5. Good. That's going to cancel those guys, and we'll get x squared equals 11, right? Okay, last step. Square root. When I square root, what do I always have to include? Plus or minus. First thing you do when you square root both sides is you're going to add a plus or minus. And then the square root of 11, I can't simplify that. If I could, I would though, right? Square root of 11 is already done. There's no, if I break 11 up into a factor tree, it doesn't factor at all. Right? There's nothing divides into it except 11. So those are my two answers. Okay, no big deal. How about something like that, one step harder? What am I going to do first? Subtract 1. So I get 5 times 4x minus 3 squared equals 216. Okay, now what? Divide by 5. Good. Right? And we're just reversing order of operations, right? Good, so those cancel. We get the quantity 4x minus 3 squared equals 216 over 5. Now what? Square root. Okay, this one looks a little bit ugly though, right? When I square root both sides, that's pretty bad. What do I do if I've got a square root of a fraction? So let's break this up into a little process here to simplify this. What do you get? Top and bottom, split them up. Good. So we've got square root of 216 over square root of 5. Now what? Say it again. Okay, so you're saying simplify that, right? Okay, we're gonna take the 216, the 5's already simplified. We can't do anything to that, but the 216, we'll make a factor tree and see if we can simplify that radical. So, 216, what's factor of 216? And we don't have to be fancy about this.
8 times 27.
Okay, so we could do, so I heard, okay, 8 works, or we could do 4, that's fine. If we do 8 times 27, that's fine. What does 8 break up into? 4 and 2, and 4 is 2 and 2. What about 27? 9 and 3, and 9 becomes 3 and 3. Okay, so then we'll count up our couples. There's a couple, and it looks like I've got 2 singles, right? So the square root of 216 is going to be on the top. What goes out front? Good. I'm going to get a 2 times a 3 gives me a 6, and inside I'm going to get 6. 2 times 3, right? Right? And then I've got my square root of 5 on the bottom. Okay? So now what? We've got a 6 radical 6 over the square root of 5. I'm not quite simplified yet, right? I got the top and the bottom as good as I can. Well, go ahead, Abby. I'm going to interrupt you. Go ahead. Good. Whatever the stranded square root in the bottom is, we'll multiply top and bottom by that. So if we do that, if I multiply by square root of 5 over square root of 5, what's that give me on the bottom? 5. Okay, there's the point. So it gets rid of the radical on the bottom. On the top, I get a 6. And what do those square roots combine to? 30. Square root of 30, which I can't simplify. I could try, but it's not, I'm not going to be able to simplify that radical. Thank you. Okay. So we got the square root of 30. 6 over 5 doesn't simplify. And so now we did a lot of work, but we got this thing simplified. So let's move on with our problem. So when I square root both sides, I get a 4x minus 3 equals. Can't forget that when I square root both sides, I need my plus or minus. And then here's what the simplified version of that radical is. So 6 radical 30 over 5. Okay? A lot of work. But from here on out, it's not too bad. Now what are the last 2 steps? Add 3. Good, good. So if we add 3, we'll just put our 3 right there, right? So those cancel. And then we're going to divide by 4. Now let's talk about that last step, because this is the one that I think people, looking at the questions I get, this is one of the more common issues people have, is how do they deal with dividing by 4 here? So dividing by 4 is fine for this one, isn't it? Right? Because I've just got a single number on top. So when I divide by 4, I'll divide that term by 4, no problem. But this is a fraction. Dividing a fraction by 4 is a little uglier. So what do we do instead? Multiply by the reciprocal. Good. Much easier, right? And what's that give me then? So my final answer looks like, oh, I'm sorry, 4. What am I doing? Yikes. There we go. So final answer. So we got an x on this side, which is what we want. Gives me 3/4 plus or minus. If I just multiply straight across, I'm going to get, now I could simplify something. You see it? Either have to do it now or later. If the 6 and the 4, right? Does that make sense? The 6 and the 4 are going to reduce. 6 over 4 reduces to 3 over 2, doesn't it? Right? If I didn't do that, if I just multiplied straight across, I would have gotten plus or minus 6 radical 30 over 20, and I would have had to reduce, that's back on, would have had to reduce the 6 over the 20, right? Either way, you're going to end up getting 3 over 10, aren't you? Right? So we get 3 radical 30 over 10. Either by simplifying right here or by multiplying straight across and then reducing 6 over 20 to 3 over 10. Okay? That's pretty hard. That's probably the hardest problem that you guys got on any of your assignments, was probably that one, I think. Okay? If you can do that, you can do any of it, I think. Questions on that? Okay? All right, multiplying complex numbers. I only gave you one like this, but let's just talk about this. If I'm multiplying three numbers, I think I mentioned this yesterday, you got to multiply them in pairs, right? So we're just going to take the first two first, just those two. If I distribute the -5, what's that give me? 20. What's -5 times 5i? -25i, good. If I distribute the -5i, that gives me positive, good, positive 20i. And then what about this one? -5i times 5i. Okay, so that's a minus 20i squared, but what's I squared equal to? What is it? No, -1. Right, remember now. I equals the square root of -1, and so if I square both sides, that's just canceling the square root, right? So I squared always equals -1. Yes, ma'am?
Isn't it 25?
Yeah,
Did I mess that up?
yeah, 5 times size.
Oh, you're right. Kind of struggling here today a little bit. That's really a convincing raindrop, but let's hold off on that. So I squared is -1. So what's that make that term then? Whenever we get an I squared, what's that do?
It's negative.
It makes it positive. So that's what you can do. Whenever you're multiplying out complex numbers, when you get an I squared, you just know it's going to change the sign. That's all it's going to do. So that becomes a plus 25. There, now everything's right. Okay. So that's what we get from this stuff. Now we can combine like terms though. So what are the like terms here? 20, 25, and 20 have no i's, so those are real terms. We can combine those. 20 plus 25 is 45. -25i plus 20i is -5i. So that's what we get from the first two. Now we just bring the third one down and just do it again. Right? I won't do it, but get the idea? We would just have to get one simplified complex number out of this, and then we just distribute again and add like terms, and we're done. Okay? How about this guy? Actually, I'm going to skip up to that guy. I want to get you working on this stuff. So what am I going to do here? Add 11. That's supposed to be a 7. So that gives me 4 times 5x plus 5 squared equals, what's -267 plus 11? -256, okay? All right, so now what? Divide by 4. That gives me 5x plus 5 quantity squared equals -64. Okay? Now what? Okay, so now we're going to square root both sides. So, talk to me about the right side. If I take the square root of -64, what's happening? What happens to the negative? Turns into an I. If I take the square root of a negative number, remember, that's always just going to become the square root of the positive number times I, right? This gives us that imaginary unit there. And what's the square root of 64? 8. So then we end up with 5x plus 5 equals what? Plus or minus 8i. Okay? Now what are the last two steps? Subtract 5. So I'll just put my -5 there. So I've got 5x equals -5 plus or minus 8i, last step? Divide by 5. Okay. Now, what if I was dividing by a negative?
Okay.
If I was dividing by, no, not inequalities. If I was dividing by a negative, remember that when I have the plus or minus term, I never divide by a negative, just divide by a positive instead. Right. It didn't work out that way this time. So my final answer then just looks like x equals negative 5 over 5 is negative 1, plus or minus 8 over 5 doesn't reduce. There's my I, right? These kinds of questions, if we get i's in our answer, they want the answer to be in the form a plus bi, right? So we need to have a real part plus an imaginary part, and then I've also got the real part minus. So if I put that in Moodle, I would just put it in like this. Negative 1 plus 8/5 I, comma, negative 1 minus 8/5 I. Okay? All right, one more, I'm going to let you work. I think that's right. Let's do this. Yeah, let's do that. Okay, this is the granddaddy of all. If you do this, you got them all. The imaginary ones. So what do? Subtract 10.
Did you steal something? No.
So I'm going to get what, 288?
Hey, had it on.
Okay.
Is there anything?
Tape it. Watch the tape.
Okay.
Watch the video. Yeah. Okay, so what's next? Divide by negative 4. Good. Negative 288 over 4. What's that going to be? 70. What is it, 72? Negative 72. Now what? Square root? Okay, what about the square root of negative 72? What's the first thing I do with that? I. Good, we got a negative. So that becomes an I. And then I've got a square root of 72. Well, I can make that simpler too. If I make a factor tree out of 72, what could I do? See if you can see a really good way to factor this. I could do 9 and 8, that's fine, it'll work, but is there one really quick way? Can I think of a perfect square factor that goes into 72, a big one? You don't have to do it this way. 36, yeah. If I do 36 times 2, that breaks up nicely. Then I just get 6 and 6. So there's my couple, there's my single. And you can do it the other way too. I mean, if you don't do it that way, it's still going to get the same answer. So I get 6 times the square root of 2i. Okay, so I'm left with negative 4x plus 5 equals what then? Plus or minus, because I square rooted both sides, that. 6 times the square root of 2i. So last two steps. Subtract 5. I'm going to put it in front of the plus or minus. Now what? Okay, divide by negative 4. So when I divide by negative 4, what goes here? 4, because it's the plus or minus term, so I don't put the negative, right? Just make it positive. And simplify, and we're done. X equals negative 5 over negative 4 is positive 5/4 plus or minus 6 over 4 reduces to what? 3 over 2. So on the top I get 3 radical 2. On the bottom I get 2 times I. Okay? Okay, give me a 1 to 5 on what we just did. So you feel like in the next 2 days you can, if you 5, if you feel like you got the tools to get ready to go for what you need to do. Okay? 1 if you're feeling like you need a lot of help. I just wanted to get an idea. Okay? Well, like a half. All right. Okay, go. Go. Work. Grab Chromebooks. I guess you get lots of questions.
Maybe.
Are you guys coming back Friday?
Yeah.
For number 2? You mean just this week? So like today or tomorrow? Yeah. Mm-hmm. Oh, you serious? Yeah, there you go. Yep, you're here. I got you.